That means it is now time to give a very warm ShmooCon welcome for the SkyScan presentation from Luke Berndt and Mike Chadwick.
Hello, ShmooCon. Really honored to be here and giving a talk. This has been a community for me. We're local in DC, so I've been bringing my kids here. This is where they learn to lockpick, and I'm really honored to be giving a talk today. So I'm Luke Berndt.
Yeah, and I'm Mike Chadwick, and thanks again for coming here to talk about airplanes and taking pictures and videos of them automatically. So we want, both of us work at a company called IQT in their rapid prototyping group, and we just wanted to walk through a project that we finished about a year or so ago called SkyScan. Thank you. And the TLDR of this project is it autonomously or automatically films aircraft that are broadcasting their position. This is most aircraft that are passing certainly through the DC area, but the majority of the world, this is sort of how it's set up. So it's designed and built out to be able to capture airplanes, helicopters, drones, ships, weather balloons, anything with a transponder on it that broadcasts its position and velocity. You can build this for about $500. We aimed for as low cost as possible. The majority of that cost is just the camera. And it's all open source, it's available on GitHub, it's all Dockerized, so it's very easy to deploy and use. We pre-built Docker containers for ARM and AMD processors, and it's portable. We've brought this in multiple places in the country, to California, Wisconsin, here in DC. We have a tripod set up and then a roof-mounted setup as well. So.
Yeah.
So the first thing to go through is ADS-B. This is part of the FAA and really the world's air traffic control system. It's a transponder technique where aircraft broadcast their position, their speed, their heading, and their climb rate. It comes in about 2 times a second. Gives you a really good position on these aircraft. One of the big features with ADS-B is it's broadcast in the clear. And that allows you to receive it with a low-cost software-defined radio. It's also mandated for most aircraft operating in sort of the civilian world. It's mandated for all aircraft. Some of the federal and DoD ones have exemptions right now. You can still get some air tankers, some military cargo flights have transponders brought onto them. And then the last thing is there's 2 frequencies, 1090 megahertz, that's sort of the global standard. And in the US, any aircraft below 18,000 feet can also broadcast on a different frequency at 978 megahertz. So to get all aircraft in America, you sort of need the two radios to receive. So in terms of receiving this, you can do this on something as small as a Raspberry Pi. You can do it on your laptop. Requires a $40-ish software-defined radio. We use the RTL SDR, sort of the low-cost SDR that's out there. Dump 1090 is a system, a set of software that's been out for a long time now. It's sort of what most of the flight tracking apps you may have used to track your airline flights are based on. You spin it up, it's containerized, so you can just spin it up, and it has a nice web UI, and you can receive all this on your local computer for any aircraft in range broadcasting.
And the fun thing, it turns into a bit of a game too, to figure out like how far away can you start receiving aircraft. It gets addicting.
Yeah, and you end up designing and building custom antennas out of PVC pipe.
It's a rabbit hole, and that's how we ended up here today.
Yes. I mentioned all the flight tracker apps are sort of fed by this ecosystem. This is really a crowdsourced industry that's FlightAware, Flight Radar 24. All of these are based on people feeding information they receive from their local software-defined radio receivers and pushing it up to the web API for all of these services. So if you've ever tracked your flight on FlightAware, that's sort of how it's happening. It's sort of a maker community pushing all that information up.
Yeah, and so this information, while it's also great and fun to like track where the different airplanes are, it's actually a lot of data coming in. So you have receivers, all around the world sending in location information about all these different aircraft. But it's also sending other information too. So it turns out a lot of the aircrafts are also reporting back the quality of the GPS information they're receiving. So there's some people out there that map where there's bad GPS information, and that's how you can start looking at where there may be jamming going on. Similarly, there's people looking at trying to look up different aircraft based upon this information and figure out who's flying where for certain events. And so this where they brought it to Davos, I think it was back in 2016, was one of the first like data-driven type of reporting that was done using ADSB information. And this is one of the first bots that was out there using ADSB information. This is from an amazing person, goes by Lemon Odor. He put together a bot network, and it simply looks for aircrafts having interesting flight patterns. So through this, you can start identifying, if there's helicopters that may be surveilling something because they're flying around in a circle. You also see different aircraft who may be sort of doing their test flights because they do really interesting flight patterns, or someone who's just doing surveying. So these bots watch, and then back when there was a Twitter, they used to tweet out, I've spotted this type of flight or that type of flight. So another interesting way to pull things and themes from this information. Of course, there's lots of people who sort of look into this. Back to some military aircraft actually broadcast this information, especially globally from other countries. So you can start trying to read the tea leaves and see maybe there's some movements here or there of different aircraft. It may signify something too. So there's a big OSINT community who's looking at this information and trying to figure out what it implies. And then finally too, there's lots of celebrity jets out there. So people have built bots around this celebrity's flying here or there, and much hilarity has ensued from tracking this.
Yeah, one of the interesting things about that, there's an FAA program to mask your aircraft's ID from places like Flight Radar 24 and FlightAware, but you have a local receiver that's receiving the same information that the FAA is, so there's no masking. You get the raw feed out of it. So it allows you to sort of do things you wouldn't be able to just do if you're grabbing from an API on some of these websites, with ADSB Exchange, I think, being one of the exceptions.
Yeah, they might be one of the exceptions. And that's the real benefit of why should I run this locally? I can just get it through an API. You get all the goods if you run it locally, so more fun for that. So ADSB information gives you a brief identifier. It's the ICAO-24 code, but you don't get much more about the aircraft. Luckily, there's some very fine data sources out there that will give you detailed information about the make, the manufacturer, the owner of the different aircraft. And so you can pivot from, here's this ADSB information, and then go and look it up. If it's a US-based aircraft, you can go to the FAA data, and this data it's chef's kiss. It's highly regulated, all the fields are filled in, it has to be updated and change of ownership, so it's all very current. It doesn't cover most military or government aircraft or any international aircraft that may be landing at Dulles or something like that. But for the majority of the aircraft you're seeing in the sky, you can get a very detailed picture of who owns it and what type of aircraft it is. For those other aircraft, there is a pretty decent sort of crowdsourced movement going on. And this is, check out OpenSky Network, they're one of the biggest ones. And so here the data quality isn't quite as good, so you have to do a bit of normalization. The example, some people typed it in Boeing, other people do Boeing Company, and similar for the model. And then not all the fields are filled in either. They may not, if you're crowdsourcing this, know who actually owns the airplane. So when we go through this, we sort of do an ensemble approach. We first look if it's in the FAA data. If it's not, then we can fall back and start pulling from that open source data too. And in general, when we've had this running, you're going to get about 90 to 95% coverage. In the DC area, we do have a lot of weird aircraft, so there's some you'll just never really know who owns or operates it. But from the majority, you'll have some pretty good idea of who it is.
Yeah, one thing to mention there is each aircraft transponder broadcasts a unique ID. It's a 24-bit registration code that applies globally. So that's how you can map from what you receive in your transponder reception all the way into one of these databases.
Yeah, and there is a program in the works for if you're fabulous and wealthy and you want to have a little bit of obfuscation on who actually owns this. You can apply to get sort of a temporary ICAO-24 code. So in that code doesn't directly link to the FAA data. They sort of have that lookup table, but it's short of that. That's another program that's in place for if you want to preserve some of your identity and you're owning a G5 jet. And back to naming things. So and this is all called from the FAA data. In most of the cases, when you look at the operator, it's pretty straightforward who that is. But at other times, we were seeing a lot of weird names pop up. I will pick on the Meatball Martini Airline LLC. It turns out if you have, a private jet or a small jet, you may have sort of fractional ownership, or you may be doing this for tax or liability reasons. So you set up an LLC to cover that versus just registering it in your name and taking on all that liability for yourself. You also see sort of that trustee there too. So if you're not an American citizen and you want to register with the FAA, you have to have it in a trustee. Or if you're leasing an aircraft, you have to have it through a trustee too. And there's a number of other reasons for having trustees too. So that's the asterisk next to. You can sort of figure out who that is some of the time. And some of the time you'll have sort of a trustee or an LLC sort of in that record instead. Okay, this is the fun part. Here's how you can build it yourself.
Yes. So the bill of materials for this is all sort of the setup to get to the actual kit here. The bill of materials is not too bad. There's really only 3 key components. There's PTZ security camera, pan tilt zoom, so a camera that can easily be steered over to some azimuth and elevation.
And eBay is your friend here.
Yes.
Like you can get the last year's models for now, and you'll be paying $350 to $400 for those. So great deals.
Yeah, 100% eBay endorsement there. We have used Raspberry Pi 3, 4, and 5. So it's not a huge amount of compute to run these systems. You can also use your laptop as long as you're on the same network as the camera. We decided to try to make everything PoE enabled. So the camera's PoE, we have PoE hat on the Raspberry Pi. Just really simplifies all the wiring. You just have one wire to everything, and a PoE switch in the middle. And then some way to mount the camera. So we've done tripod mounts, we've done pieces of wood on a roof.
You'll see some very embarrassing non-engineered approaches.
So this is, there's some optionality here, so you can pick and choose whichever camera makes sense to you based on how much money you want to throw into this and what you have available to you. And then really the compute is pretty much anything you want. So that's pretty much it.
And I'll note the high end, you can get very expensive with this too. There's really nice cameras if you have the money to spend.
Yeah, and then in terms of camera specs, what you're really looking for here, like the most important is positioning accuracy. We've had really good luck with Axis security cameras. You give them an angle to point at, and it gets pretty much within 1/10 to 100th of a degree every time. Very reliably. We've had them on roofs outside for 1.5 years at a time, unattended, unmaintained, and they just keep working, no calibration. So,
and they have like a well-documented API too. And they'll have MQTT messages they can send out on status and everything. It's a mini web server attached with the camera, which actually may alarm all of you too, because some of those haven't been updated in years. So,
yes, that is true. A field of view and zoom. So this depends on how far away you want to image aircraft. We've used a 32x and a 40x optical zoom. And we're seeing things out to 40, 50 kilometers or so when they're up in cruise altitude. And then resolution is the other piece here. So once you get zoomed in, the higher resolution, the better, but that comes with additional cost. And then can't stress the PoE enough. That just simplifies everything so much. Just one Ethernet cable, and then you're pretty much good to go.
Yeah. I've been amazed on the weatherproofing too. Like we've done nothing special, took it out of the box. They were supposed to be weather rated, but this has survived snowstorms, rain, and everything, and it keeps on ticking.
Yeah, so this is the myriad of different configurations we've fielded. The right is the most ruggedized version, but we've had the sort of 2x4 special on top left, cinder block special on the bottom, and then we have a portable tripod mount that we use for going out and making sure everything still works. We'll often set up down in DC at Haines Point across from DCA and just track the aircraft there. So a lot of different options here for setting it up.
Yeah, and for the portable side too, we were just bringing one of those small battery banks with us too, and that's gotten us a day's worth of power. So they're not super power hungry, especially if you don't have the heater or any of the special things turned on. Okay, so this is a bit of the special sauce, and we have all the code up there, so you can go in and sort of look how it works. But this will be the sort of the flyby, just so no pun intended, so you can get a sort of sense of how we're doing this. So you start out just knowing where the camera's located, you know its longitude, latitude, and altitude. And then from ADS-B, you're getting where the plane's located, its longitude, latitude, and altitude. With a bit of math, you compute that, and you'll get the azimuth and elevation.
Fair bit of math.
Fair bit of math. It looks really scary, but the computer handles all that for you. So with azimuth and elevation, the azimuth is, just think about it as that's the pan and the pan tilt zoom, and the elevation is that tilt. So every time it gets in an update of where the plane is, it can then calculate where to look. But there's little tricks in here. So at best, you'll get an update on location every 2 seconds, and for the altitude, it's even less frequent, maybe about every 5 seconds. And that's the sort of best case scenario. A lot of times, if your antenna's coverage isn't great or you have something blocking it, you may not get that many updates.
Or even if you get just flooded with messages.
Yeah.
There's so many airplanes that fly around here, so it's you get collisions a lot.
Yeah. So luckily you have sort of the vertical velocity and horizontal velocity of the airplane, so you can interpolate where to look. And that lets us do the smooth tracking you saw earlier, where you can have a smooth track. It looks, I don't want to brag, but it's sort of movie-like. So that helps a lot there. And that's just an example of how we're able to sort of interpolate those positions. So again, check out the code. It will give you a better sense of what we're doing to calculate that. Finally, as you go to set this up, just give us a ping, but also it does take a little bit of time to have everything leveled and figure out your orientation of the camera. We're down to 1 or 2 degrees in there, so you do have to have some precision as you sort of level and locate that. And you can do that both physically, and then we have some controls and software to just sort of tweak it back and forth. Finally, as Mike was saying, there's a lot of airplanes out there. There's a lot you can actually hit within a 40-kilometer range, so you sort of have to do some prioritization. It can be what's closest or what's most interesting.
Yeah, the what altitude is your threshold is really helpful for when there's weather. If there's 8,000-foot ceilings, you don't want to target aircraft above 8,000 feet. You want to look at things below if you're trying to take pictures. So. And then the process here, we designed this, we tried to take a modular containerized architecture for this. So everything is built into a container. PyAware, we mentioned that earlier, that's the system that FlightAware maintains. That's sort of the backbone that runs dump 1090 underneath. That it creates a JSON file that we then grab and then push into a tracker module. An object tracker, it's really just any object out with a latitude, longitude, altitude, velocities, and heading, it can track. So we've put weather balloon data in there, ship data, it's designed to be robust in that way, but this implementation just uses aircraft. And then the camera pointer does all the math to figure out what do we prioritize, and then what do we point the camera at, and then the camera API is what does the rest of the work, actually steering over and then taking the imagery.
Yeah. So, yeah, we have lots of good photos, and we spent way too much time and had way too much fun trying to get them all on here, but, come find us later if you want particular photos of any type of aircraft. We probably have one. Which brings up an interesting point. So if anyone's been watching the news recently, this is straight off of NBC's webpage. There's been a lot of interesting stuff in the sky. And
Real interesting.
Actually, we look at a lot of airplane photos. So this was like, wait a second, I think I've seen something similar. So, went and looked at some footage we had, and it's like, that's really similar. So point here is, as you start taking photos of images, you get a better sense of sort of the known. What is normal and what's not. And that's really helpful for you to help you focus on what is weird out there. So I think that's one of the values of doing this is you can start capturing what is around you, figuring out what that normally looks like, and then it makes you more attuned to the things that aren't that. So hopefully, having more people doing this will get more people aware of what's out there and what's around there and what does look normal. So this is, why we're here. We want to help people build this. It's a lot of fun, but I think it also gives everyone in the community a better sense of what's in the air. And it helps educate everyone. So come find us. We're really interested in talking about that. And there's...
Yeah, the only thing I'll add to that is you really want, if you're trying to figure out something like the New Jersey drone situation, you want to be able to very easily clear off the things that are false alarms and just prioritize the things that are weird or anomalous or something that shouldn't have been there in the first place. So helping you separate out get the wheat from the chaff.
Yeah, so. Yeah, and there was a lot of chaff, I think. But it turns out the other thing is you have great labels from the FAA. We have a lot of images. You can also start building models, too. So yeah.
Yeah, so caveat, we're not the data scientists here, but we have the nice thing with that ICAO ID is it's a unique identifier that you can then use as FAA databases to blow up into very rich metadata labels for all the images that you collected. So you can draw bounding boxes around the aircraft and then train up either localizers to find aircraft in just regular camera pictures, or do classifiers that you can run in real time and sort of say, is that a 737, A320, 787, sort of so on and so forth. And this is a really fast way to collect a lot of pretty rich data. You have to do some manual tweaking because a lot of it's still out of focus, some of it's behind clouds, those kind of things. But we've used this to train a number of ML models to pass across imagery and videos in the past. So.
Yeah. I think that's it for us. I think one thing to add at the very end is go check out our code. It's up there. We want people to run it, so ask questions. And then also, In-Q-Tel, or IQT, is a fun place to work, and we're hiring. So come check out iqt.org/careers, and also come talk to us. We'll be in the hallway and then maybe up at the bar after that, so come say hi.
Thank you all for the time.